In this video, I'm going to discuss two-dimensional geometric transformations. So, 2D geometric transformations. Under this topic, we will be discussing five subtopics. First one is translation. Second one is rotation. Third one is scaling. Fourth one general pivot point rotation. The fifth one general pivot point scaling. Now let's try to understand the first one. Translation. Um, this is the y-axis and this is the x-axis. Here we have the origin. Suppose we have a point here with coordinates x comma y. This point is moved along the positive direction of x-axis by an amount of tx, and along the positive direction of y-axis by an amount of ty, and it comes to this position. So the coordinates of this position is x1 comma y1. Let's take it like this. So now we can write down x1 means x plus tx, y1 means y plus ty. Now, when we deal with geometric transformations, it's easier if we represent, uh, if we incorporate the idea of matrices to geometric transformations, then it's easier for us to manipulate. Therefore, let's represent these coordinates, this point, using a matrix like this. Here we have two rows and one column. Now we can similarly we can represent this one like this. No, we can represent this like this one. So now we have this 2 cross 1, the matrix that represents this point, and here we have the matrix that represents this point. Now we have to find a way to transform this matrix to this one. Let's say let's put another matrix here. Then we are going to find, if we multiply these two matrices, we should get this one. This one means, again, x1 means what? X plus tx. y1 means, from here, y1 means y plus ty. So here we have 2 cross 1 matrix. Now what is the type of this matrix? In order to be able to multiply these two matrices, definitely the type must be something cross 2. Here 2, here 2. So now here we have 2. The number of rows in this matrix is 2. Therefore, here we should have 2. Therefore, the type of this matrix is 2 cross 2. That means we have 2 rows and 2 columns. Now, can we find such a matrix? So let's try now. In order to get this term, what should we do? We can put here 1, we can get x. No y terms here, we can put here 0. Then what happens? We can get x plus 0, but we cannot get tx term. Therefore, we cannot find a 2 cross 2 matrix that transforms this one to this. Therefore, we have to think, how can you do that? Let's represent this point like this. y1. Now we have additional element. This is a 3 cross 1 matrix. There are 3 rows, 1 column. First 2 elements represent the coordinates. This one is always 1. The value of this element is always 1. That means if you want to represent this point using a matrix, we simply put x1, y1. These are the coordinates, and here it is 1. This is always 1. Okay. So now this one is a 3 cross 1 matrix. Now here we have to find the matrix. And again, what is this? 3 cross 1. x1 means x plus tx. y1 means y plus ty. Here it is 1. Now we have to find the matrix, this one. If we multiply these two matrices, we should get this. So now here we have 3. In order to be able to multiply these two matrices, the type must be something cross 3. Here 3, here 3. Now in this matrix we have 3 rows Therefore, here it must be 3. Therefore, this is a 3 cross 3 matrix. There are 3 rows and 3 columns. Now, let's try now. In order to get this particular term, we have to multiply the first row of this matrix by first column of this matrix. Now, we have here x. Therefore, if we put 1 into x, we can get x. No y terms here. Therefore, this element is 0. Tx. If let's put tx here, then what happens? So if we multiply 1 into x, we get x. 0 into y 0. Tx into 1, we get tx. Now similarly, we can fill other 2 rows. Here we have now y plus ty, therefore 0 into x, 1 ty. Then we get 0 y t plus ty. Finally, here we should get 1. Therefore, 0 into x, 0 into y, 1. Here we have 1. So, now this matrix, if we multiply these two matrices, we get this one. In other words, this matrix can transform this one to this. Therefore, we call this the translation matrix. And we represent it like this: capital T, Tx, comma, Ty. 2 parameters. This is the amount along the positive direction of x-axis. This is the amount along the positive direction of y-axis. That means here we say this point translates to this point by tx amount along the positive direction of x-axis and ty amount along the positive direction of y-axis. So this is our translation matrix. Now let's move to the next topic. Scale. So we have y-axis here and x-axis here. So we have the origin. Now we have a point with coordinates x, y. Then this moves to another. This point moves to another position. It is x1 comma y1 such that x1 means sx into x, y1 means sy into y. These two values sx and sy, we call them as scaling factors. So now this is also a transformation. We call it scaling. That means this coordinate is scaled. This one is also scaled by a factor. Okay. So in order to understand this, now earlier for translation we represented translation this matrix. This was a 3 cross 3 matrix, and we represented coordinates in this format 3 cross 1. Therefore, in order to maintain consistency, here also I will represent points using a 3 cross 1 matrix like this. First two values represent the coordinates, and last one is always 1. So now here we have x, y, 1, 3 cross 1 matrix. Now we have to get this one x1, y1, 1, 3 cross 1 matrix. So this one means sx into x, sy into y1, 3 cross 1 matrix. Now we have to find another matrix such that when we multiply these two matrices, we should get this. Now again, in order to be able to multiply these two matrices, the type of this matrix must be something cross 3. Here 3, here also we have 3. Now number of rows in this matrix is 3, therefore here it should be 3. Now this is the 3 cross 3 matrix, and in order to get this term sx 0 0, now you get this sx into x 0 0. In order to get this 0 sy 0 0 0 1, we get this one by last row multiplying this column. Now multiplication of these two matrices, by multiplying these two, we get this one. In other words, we can use this matrix to transform this matrix to this. Therefore, we say this type of transformation, we call it as scaling, and this matrix we call it the scaling matrix. So we use capital S, and here we put scaling factors here as the parameters. Now let's look at the next topic. Rotation. So this is the y-axis and this is the x-axis. Here we have the origin. We have a point with coordinates x comma y. So this point is rotated around the origin by an angle of theta, and it reaches this position by an angle of theta. So the coordinates of the new position is x1 comma y1. Now this kind of a transformation, we call it as a rotation. So it rotates, this point rotates around the origin and comes to this position. So now let's take this angle as alpha. And let's complete these two triangles. This one and this one. So if we consider this particular triangle, so we can write down x1 means, now this length, let's take this length as r, here to here. Since it is a rotation around the origin, this length is also r. This length r, then this length is also r. So here x1 means, now x1 means r cos theta plus alpha. Again, let's consider this particular triangle. Here x means, if you consider this triangle, x means r cos alpha. Sorry. Y means, if you consider this triangle, y means r sin alpha. Now, if you expand this, r cos theta cos alpha minus sin theta sin alpha. Again, this one you can write down r cos alpha cos theta. Then this one minus r sin alpha sin theta. So we substitute r cos alpha, we substitute x cos theta minus y sin theta. This is our x1. Then again let's try to get y1. If you consider this triangle, y1 means r sin theta plus alpha. If we expand it here, r sin alpha, sin theta cos alpha plus cos theta sin alpha. Now again this one we can write down r cos alpha sin theta plus r sin alpha cos theta. So here r cos alpha, from here we can substitute x sin theta plus r sin alpha. Here we put y cos theta. So now we have got here this one and this one. We have computed x1 using x and y, y1 also using x and y. Therefore let's write it here. x1 means x cos theta minus y sin theta. y1 means x sin theta plus y cos theta. So now we have derived these two results. Now again in translation, this was our translation matrix. Its type was 3 cross 3. This was our scaling matrix. Its type was 3 cross 3. So now we are going to find a rotation matrix. In order to keep the consistency, here we are going to find are rotation matrix. In this situation, we have only one parameter theta. The theta is measured from positive direction of the x-axis in anti-clockwise order, theta. So this is, we have to find a 3 cross 3 matrix, and in these two situations we have represented the point like this using matrix, using a 3 cross 1 matrix like this. So now in order to maintain the consistency, we use the same 3 cross 1 matrix to represent coordinates. Now here we put this x, y, 1, 3 cross 1. Now, so let's put it somewhere. Not here, let's put it here. X, y, 1, 3 cross 1. It is this one. So this point is rotated to here. This is a transformation called rotation. So it is rotated from here to here around the origin. So now here we get this matrix x1, y1, 1, 3 cross 1. This one means now 2x1. Now if we are given the coordinates of this point, now this point is rotated around the origin by an in anticlockwise order around the origin by an angle of theta. So if this is the destination, these coordinates we can compute. We could derive like this. So now here let's write down x1 means x cos theta minus y sin theta. Y1 means x sin theta plus y cos theta. Here it is 1. Now here x cos theta minus y sin theta, x sin theta plus y cos theta. From here we have substituted. Now here we have to find the matrix such that if we multiply these two matrices, you should get this. Then we can say this is the transformation matrix. So in order to be able to multiply these two matrices, what should you do? The type should be something cross 3. Here 3 and here 3. Now number of rows in this matrix is 3. Therefore here it must be 3. Therefore this is now this is a 3 cross 3 matrix. Now in order to get this term x cos theta, here we put cos theta minus y sin theta minus sin theta, here 0. Now you can get the first element in this column, x cos theta minus y sin theta. Okay. Now in order to get this one, x sin theta, here we put sin theta plus y cos theta, 0. X sin theta plus y cos theta plus 0, and here it is 0, 0, 1. Then you will get this one. Now if you multiply these two matrices, you get this one. In other words, this matrix is transformed to this matrix using this matrix. So we call this the rotation matrix r theta. If we rotate a point around the origin, that is important. So when we derive these two expressions, we consider the origin. So if the point of rotation we rotate around the origin, then uh, this is our rotation matrix. So now let's move to our next topic. General pivot point rotation. So now we have origin, x-axis and y-axis. We were discussing about rotation and rotation matrix, but our pivot point was the origin. Now here pivot point means we select a point, general point. Let's say x naught comma y naught. This is our pivot point. So if we have a point like this, we rotate this point around this point by an angle of theta. Then let's say coordinates are x1 comma y1. This is called general pivot point rotation. Now how can we derive the transformation matrix for this one? So initially this is our three cross one. This is the matrix that represents this point. So first, what should we do? Here we put T. We perform a translation with translation factors minus x naught and minus y naught. What is this matrix then? 1 0 minus x naught, 0 1 minus y naught, 0 0, 0, 1. So, in order to simplify the understanding, let's think this is this. What happens when we multiply these two matrices? What we are going to get? We will get 0, 0, 1. That means this matrix represents the origin. That means if you use this point here for this matrix, when we apply this transformation matrix, this will come to the origin. This will come to the origin. This to origin. Then this is a translation. No? Therefore, with same amounts, if we apply it to this point, what do you think? If we apply it to here, we use x and y, then it will come to somewhere here. This point will come to somewhere here. So its coordinates, let's say this is our position 1, this one. So this is the matrix that corresponds to this position. Now this point, what should we do? Another 3 cross 3 matrix. We now here we put R theta, the rotation matrix. This is the matrix we derived earlier, rotation around the origin. Now this is a rotation around the origin. So let's say this is our position 1. Now it rotates by an angle of theta. So we can get this one. So now here let's put cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. So now if we apply to this one, this matrix, we apply rotation matrix around the origin. So we get this one. This is our 2, position 2. So now we will get, these are the coordinates of this point. Again, now our goal is to compute the coordinates x1, y1. So in order to get this, what should we do? First, we performed a translation. Then we rotated around the origin using this matrix. Again, we have to retranslate. Here we put t x naught comma y naught matrix. So here 1 0 x naught 0 1 y naught 0 0 1. This is a 3 cross 3 matrix. Now if we multiply these two, you will get a point. Let's say 3 cross 1. So that means this point, this is position 3. So we will get x1, y1, 1, 3 cross 1. This is position 3. So I will summarize what we did. That means we have had the point x, this one. So we had to rotate the point around this point. So what we first did was we had this point, a 3 cross 1 matrix. So minus x naught minus y naught, we translated. We first translated the point to here. Now it is a problem of rotating around the origin. Therefore, we simply used r of theta, rotation matrix, that we derived earlier. Again, we have to reverse the translation. So here again we put x naught, y naught. And then finally we could get x1, y1, 1, 3 cross 1. So that is what we did here. So now if we get x1, y1, 1, 3 cross 1, we can multiply these three matrices and then you can get this one. Cos theta minus sin theta minus x naught cos theta plus y naught sin theta plus x naught. Here we have x, y, 1, 3 cross 1 matrix. So if we multiply these three matrices, you will get a 3 cross 3 matrix. 3 cross 3 matrix. So this one cos theta minus sin theta minus x naught cos theta plus y naught sin theta plus x naught. Then sin theta cos theta minus x naught sin theta minus y naught cos theta plus y naught 0, 0, 1. So I'm not going to show you how to multiply these three matrices. Anyway, once you multiply these three matrices, you will get this one: cos theta minus sin theta minus x naught cos theta plus y naught sin theta plus x naught sin theta cos theta minus x naught sin theta minus y naught cos theta plus y naught, then 0, 0, 1. So this matrix we call this as the composite transformation matrix for general pivot point rotation. That means now this matrix we use to represent this point. This matrix we use to represent this point. So if this point rotates around this point by an angle of theta in anticlockwise order, then we can use this matrix to transform this matrix to this one. So this is our composite transformation matrix for general pivot point rotation. So now hope you understood this section. Now let's move to the last section. Now let's discuss general pivot point scaling. So here we have y-axis and here we have x-axis and origin. So again we have a point x naught comma y naught. This is called the pivot point. We have already discussed scaling metrics. They are actually what happens. Capital S, simple s x, simple s y. So these are the scaling factors. So uh, if this point is scaled to this one, actually what happened? So x1 was sx into x, y1 was sy into y. This is scaling. Actually, here we use the distance to the origin. X coordinate means actually the distance to the origin. Y coordinate means it's also the distance along the y axis. Uh, so distance, not sorry, x means actually not along the distance means if you consider a particular point along the x-axis distance to the origin. Okay, that's what I mean here. X means if you consider the point along the x-axis, the distance is x. So this matrix we call this the scaling matrix with respect to the origin. So here we want to scale with respect to a general pivot point. It is this. So we have this point. So this one we have to scale with respect to this point. Let's say it goes somewhere here after scaling. This is what we have to compute. Now here we have x, y, 1, 3 cross 1. The matrix that represents this point. So as in general pivot point rotation, you can understand this. First we put translation matrix t minus x naught minus y naught. So after applying, if we apply here, if we had this point, it will come to the origin there. So this one will come somewhere here. So this is our position 1. So now once we have applied this one 0 minus x naught 0 1 minus y naught 0 0 1, we will get the matrix that represents this point. So now we can scale with respect to the origin. So here we apply capital S, Sx, Sy. Sx 0 0 0 Sy 0 0 0 1. So when we scale let's say it moves here. This is the matrix corresponding to this position. Now, what should we do? We have to again reverse the translation. So here we have to put 1 0 x naught. So this is our this matrix T x naught comma y naught matrix. 0 1 y naught 0 0 1. So after that we will get a matrix that represents a position 3. So this will give us x1 y1 point. So if you compare this with general pivot point rotation, you can easily see the relationship. So what we did, we had the point x1 xy, yes, this we had the point. So first what we did, we translated to the origin, then we scaled it with respect to the origin, again retranslated, and finally we could get x1 y1 1 3 cross 1. This is what we did here. So as usual, we can multiply these three matrices. Their types are 3 cross 3. So here we can write down this x1 y1 1 3 cross 1 matrix, and so here this one we will get this matrix Sx 0 1 minus Sx x naught. This one xy1 3 cross 1 matrix. So here 0 sy 1 minus sy y naught. Zero, 0, 1. So here we get a 3 cross 3 matrix. Now this matrix is called the composite transformation matrix for general pivot point scale. That means if you want to scale this point with respect to this pivot point, so we can use this matrix. Okay, so now let's summarize what we discussed in this video. We were discussing about two-dimensional geometric transformations. First, we discussed about uh, translation, and translation matrix is this one. We represent, we use this notation. Tx means the amount along the positive direction of x-axis, and dy means the amount along the positive direction of y-axis. So a point moves tx amount along the positive direction of x-axis, and along the positive direction of, sorry, y-axis by an amount of dy. So this transformation we call it as translation. So now after that we discussed about scaling. These are the two scaling factors. We have 1 point. So if we have its coordinates are x comma y, then it becomes sx into x, sy into y. So this is scaling with respect to the origin. So here actually, if we consider x comma y point, x means the distance to the origin along the x direction. So we multiply it by the scaling factor. Y means the distance along the positive direction of y-axis. So we scale it by sy. This is scaling with respect to the origin. Now we discussed about r of theta. This is rotation. If we have a point theta, we measure in anti-clockwise direction. So if point rotates around the origin by an angle of theta, and it reaches this position, so then we use rotation around the origin. Once we have discussed these three matrices, then we discussed two things: general pivot point rotation. That means if we want to rotate a particular point around another point, then this point, in order to compute the coordinates of this point, we can use general pivot point rotation, and we can use that composite transformation matrix. And after that we discuss general pivot point is scaling. That means if we have a point like this is our pivot point, we have another point. If we want to scale this point with respect to this one. So that is called general pivot point scaling. We can use once we have scaled, if we get another position, the coordinates we can compute using the corresponding composite transformation matrix. So those are the things I wanted to discuss in this video. Hope you understood very well, and thank you for watching.